Mrs. Armstrong already wrote up Unit 1B, area, day 5. We're doing composite figures. I don't like to say this often. I haven't, after 12 years, I still haven't found a great way to teach it. That bothers me. I've tried lots of different methods. I've tried lots of different ways, and I haven't come to one that I thought would be great. So we're going to try a different method this year. And hopefully this is the year that I'm like, yes, I love this. But it's going to be an experiment. So you guys are like my experiment class. That's a long way down there. So first off, what do I mean by composite shapes? Because we're going to be finding the area of a composite figure, a composite shape, anything like that. First off, all of the shapes that we're going to be using today are already on the board where it says area formula. Okay? The composite shapes more than, nope. See, I told you, I don't, let's try again. A shape that can be partitioned, which means broken into, that can be partitioned into many separate shapes. I like that. So a shape that can be partitioned into many separate or different shapes. Today, all we're going to be doing is naming the shapes and writing what we know about them. What do you mean, Mr. H? We're confused. You said you're a crappy teacher at this. Never said that. Don't say that, Maddie. That's mean. I'll throw this wet rag at you. Don't say that. That's rude. So, here's my first example. In our composite shapes, everything that we will be doing today, tomorrow, and Thursday will only be including these 5 shapes: squares, rectangles, parallelograms, trapezoids, triangles. If you know these formulae, you will be just dandy. So here's my question. What 2 shapes do we have? What do you think?
Somewhat of a square.
Okay, possibly a square. Carly?
A rectangle and an obtuse triangle.
A rectangle and let's just say a triangle. Okay? How do I know it's a rectangle? Well, if these are 90 degrees, right? The sides are not the same, so it's not a square. We need to say, okay, our best guess is it's going to look like a rectangle. And now we're taking our best guess of what it looks like. Everybody with me? But then we've got this thing that looks like it could possibly be a triangle. So now let's do this. I can dash this line. Everybody still with me? Which means This is also 90. This is now 90. But now I've got a triangle. Everybody with me? This side is 12, this side is 10. Good. What does this part of the triangle have to be? What does this have to be, Taylor?
12.
12. How do you know that?
Because
What do we know about a rectangle? Opposite sides are congruent. So if this is 12, this is also 12. Now, let's keep breaking it down. If this is 10, what does this side have to be, Avery? 10. But wait. We've still got other things we've got to find. What about this part of the triangle? Rebecca? If this is all 16, the whole thing 16, but this portion is 10, how can I find out what just that top part is? What can I do? What do you think? Am I going to add them together? Am I going to subtract them? Am I going to multiply them? Am I going to divide them? If I know that the whole thing is 10, but the whole thing's 16, but part of it's 10, how can I find what's left over? Let's get some help. Cece?
16 minus 10.
Yeah. I'm going to subtract. 16 minus the part we know is 10, so this up here is 6 feet. Now, this was a very poor example because really that's a trapezoid. You could have just solved it like a trapezoid, but I'm glad that we did triangles, rectangles. I want you to start to see the figures. Everybody still with me? We're not finding area at all today. All we're doing today is going to write the measurements that we know. Okay? I'm trying to break this down as much as possible. Tomorrow we'll talk about area. That's the easy part. The hard part is writing down what we know. "24 feet, 16 feet, 5 feet, 5 feet, 8 feet, 8 feet." So not everything is given to you. We have a couple different ways that we can go about finding these shapes. What shapes do you think we're going to break this down into? Are we going to have squares? Are we going to have rectangles, triangles, trapezoids? What shapes are we going to have? Cece? We could have squares, we could have rectangles, probably just rectangles, because I don't see any sides that are exactly the same. Does that make sense? Okay. So we have two ways that we can break this down, truly. We can break them into rectangles by going like this, and then I have a rectangle, a rectangle, a rectangle. Or we can break them into rectangles going across. There is a way that I would do it versus another, but are either of them wrong? No. So please make sure that you copy it down and then we're going to redraw the figure and do it again. This is how I would break it down, and here's why. I know that this right here is a rectangle that has a side of 8, has a side of 5. Which means, what does this dashed side right here have to be?
8.
Luke?
8.
8. So I'm going to write 8 feet. What does this side have to be? What does just this portion right here have to be? 5. Because if this is 5, this is 5. And to show that it's just that portion, maybe I'll draw a little line like that. Everybody with me? Still with me? Yes? Okay. If this is 8, what does this one have to be? What's this side right here? The dashed line again have to be? Jess? 8. Now we've got a problem. This whole thing was 16. So I'm going to erase this and just move it out a little bit. So this whole thing was 16 feet. So from the top to the bottom. What is just this portion from the top to the dashed line? 5. How do you know that, Owen? Opposite sides are congruent. Okay. Now I'm going to switch markers. So we've got this rectangle, we've got this rectangle. Now we've got this big old rectangle. Everybody with me? Yes? We know this is 24 feet, which means from here over is also 24. Does everybody agree with that? How am I going to find these sides? Emma? Very good. Did everybody hear that? Can you say it one more time? 16 minus 5. We've got this portion and we've got the whole thing. So we take the whole thing minus the portion that we know, which gives us 11 for both sides. So now we've got a rectangle, an 11 by 24. We've got a 5 by 8. We've got a 5 by 8. Have that written down. That's personally, I think, the best choice. Unfortunately, my mind does not see it that way, ever. I hate going across. That's called horizontal. I don't like drawing dashed lines horizontally. I don't know why. I truly don't know why. So what else could I do? Well, let's redraw the same figure with the same starting numbers. So this was 8 feet. This was 16 feet. This was 5 feet, 5 feet, 8 feet, 24 feet. Mr. H, if you don't like drawing them horizontally, what do you like doing? Well, I like drawing them vertically. So now, if this is 8, this is 16, from here all the way down is 16. From here over is 8. Does everybody agree with that? That's the easy part. Well, if this is 16, what does this side have to be? 16. So from here down is 16. Okay. Well, now I'm in trouble. And this is why the first way was easier, because we only had to find this 11 foot. This requires a little bit more math. I'm not going to lie, it does. So we had 24 feet was the whole thing, right? How are we going to find out just this missing part? Come on, no, Taylor, go ahead.
You add 8 plus 8.
Which is?
16.
Okay.
You subtract that from 24.
Very good. Did everybody hear that? We know that this portion is 8. This portion is 8. The whole thing is 24. So we need to find this missing part. So we add up what we know, which is 16, and then we take it away from 24. So 24 minus 16 leaves me, 8. So if this is 8, what does this top have to be?
8.
Ruh-roh. Yeah, that's right. 8, 8, 8. Okay, shoo! Shoo, shoo, shoo. Mr. H was having a little mental breakdown there. Good there. Uh-oh. How do we find these sides? What do we do to find the sides? What do you think, Taylor? The whole thing's 16, but this portion's 5. What do we do to find the sides?
16 minus 5.
16 minus 5, which gives me 11 feet. Folks, this is just going to take some work. I mean, again, I told you at the beginning, I haven't found a foolproof way to teach it. Before, I would show you this and say, let's find the area. No. We're just going to break them down. That's it. You are going to have some work. We're going to do it right now. We're going to do them together. Okay? So, notes, there really weren't notes. It was some practice examples. We're going to keep doing some practice. Yay, math.